Hi, this is Josh with Glow Labs. Yesterday I was sent the electric imp development board to test out, and I'm just going to share with you some of the findings I had with it and show you a quick overview of how it works. It's designed to be a IoT platform. So Electric Imp has their own chip. It's a Wi-Fi enabled device that gets on your local network and then can communicate to the Imp cloud. And from there, it will interface through APIs as well as handle HTTP requests from third-party servers. So here is the board itself. This is the development board. It's got a number of onboard sensors. It has a temperature and humidity sensor, a accelerometer, a pressure sensor, a RGB LED, and then it's got headers for inputs and outputs. Coding the board is very simple. We use their Electric Imp online IDE, and the setup process to the board is very simple. You just download their app, and it paired within 30 seconds or so. It was extremely painless. There's two features, or two panels here. The right side is the device, so this is the code that sits on the device, and the left side is the agent. This is what runs on the Imp secure cloud server. So on the device, I won't go through this in much detail, but basically it's similar to how you would set up an Arduino board of requiring devices, assigning settings and configurations for them, and then reading the data. So here's a quick example. We're going to read from our temperature humidity board, and we're going to get a result, and we're going to store that in an object. So it's very basic, or basic is the wrong word. It's very easy to use, but gives you a lot of power. So yeah, I'm reading the data here, and then when I'm done reading the data, I just say agent send, and I'm passing the data to the cloud server. When I receive the data from my device, I call a function called report data, and that assigns the data received to an object. And that's really all you have to do. We can log the object and see the different properties for each device. What I've done is create a little HTTP server on here to handle requests, and it will send out that data as a JSON object. So this was all running fine, and I decided to make an iOS app just to test it out. So to do that, I built the backend server in Node.js, and this is the entire server. It's 40 lines of code. It's a Express app with Socket.io. We are requesting data from the Imp cloud to get its current data, as well as sending commands to it through its HTTP protocol. And then we're communicating with our app through Socket.io, and basically we're just listening for commands from it. So here is our iPhone simulator, and we just created a little app. That loads up, and we can click here to control. And if here is LED control, if we click blue, the LED will go blue, green, red, off. We can control the GPIOs on the board. And down below, we're reading all of the sensor data. So it's pulling the current temperature, humidity, air pressure, and accelerometer data. And here, if I rotate the board, you'll see the accelerometer data is changing. And I just did this as kind of a quick and dirty project. I'm pulling the data 10 times a second. So that's why it's a little slow, but it's enough to show the capabilities of the system. I took it one step further just to see if I could pair it with a Amazon Echo device. Alexa, trigger LED red.
Sending it to it.
And so you can see here that through the Alexa command that we're controlling the LED. Alexa, trigger LED off.
Sending it to it.
So that's just a quick overview of the Electric Imp development board and their platform. It's a great tool for quickly prototyping IoT devices, and through their manufacturing process, you can actually get devices to market very quickly. And another very cool feature of the Imp is you can push cloud updates to it. So it's very easy to update the firmware on the device and update your code even once the device is deployed. So I hope this was useful, and we'll be doing some more projects with the Electric Imp in the future, and look forward to playing with it.